Okay, good afternoon. It is Thursday, November 7th, and we are about to do homework for lessons 13 and 14, and we haven't gotten to that in class, but that's okay. That's why we are taking some video notes all together. There aren't any graded questions. And if you went ahead and worked on them first with the pencil, that's great. And then you can take the video notes with your pen or just your Flair pen or just any other non-pencil. Okay. First, I want to show us a special math. Why is it saying offer? No, I do not want this offer. Okay. A special math object or, shape. Okay. An isosceles triangle, this is the official name for it, is a triangle that has two equal sides and two equal angles. It's part of the family of triangles that also talks about side length and angle measurements. The other ones are, I'm just gonna move up. The other ones are equilateral triangles. That's all three sides are the same length and all three angles are the same. And then a scalene triangle, it means all three sides are different and all three angles are different. But an isosceles triangle, you just have to understand this is the name, that's how you pronounce it. This means two equal sides. Okay, so the joke is, which triangle is the coldest? An isosceles triangle. All right, one more. Isosceles, it's not how it's spelled. Okay, okay. And the last joke of the week is what do you call a snake that is approximately, that's what those two little squiggly lines mean, approximately, these are squiggly lines, approximately 3.14, and that is the mathematical number for pi, which in Greek letters looks like this. It's like two columns with like a squiggle on top, which is why they drew the shape of the snake this way. But anyways, pi is an important number in math, and it means it's the distance around a circle compared to the distance across, and it becomes pi, which is the circumference, the distance around, the circumference over the diameter, which is the distance across. Okay, diameter, there we go. It's a little bit harder to write. But anyways, the circumference divided by the diameter is this number pi, which actually continues on forever and ever and doesn't ever stop. And it's like 3.14, blah, blah, blah. And the cool thing about pi is that on March 14th, 314, we have a pi memorizing competition, and the student who memorized the most amount of digits of pi can pie a teacher in the face. But anyway, a Python is funny because Python in the real world, not in the fun math world, but a Python is spelled with a Y, not an I. So that's our math joke, our math pun for today, or the second one. Okay. Let's get working on lessons 13 and 14. Again, if you have any thoughts, questions, or conclusions, please write them there. I'm happy to answer them, give you beat points, and just like love all of the thinking you're doing. Okay. So today, or in the future, we will learn to divide a whole number by a unit fraction. This is actually really cool. So I have a strip of paper that is 2 feet long. So like I told you, the tape diagrams we're using or the bars that we're using have to be defined, letting us know the size of 1 so that we can identify that this is actually 2. Okay, so you can't just assume that it's 1 anymore. Sometimes it becomes like a fraction and a piece. So you just want to make sure that you define it every time you draw it and look for it. If I cut this 1 foot into pieces, that would be 1/4. When I cut it into 1/4 and I have 2 of them, it actually doubles it. So how many pieces in the 1 foot? Oh, 1, 2, 3, 4 pieces. And how many pieces in the second foot? Another set of 4 pieces, because 2 divided by 1/4 is 4 sets of 2. So again, multiplication plays a role in our work here, because if we have 1/4 of 2, I have 4 pieces in one of them times 2. So I will divide each foot into 4 pieces. Since there are 2 feet, I will have 4 sets of 2 or 2 sets of 4. Multiplication doesn't, the order doesn't change the product in multiplication, and I will have 8 pieces in total. So that's pretty cool. Notice my divisor is super duper small. That's why my quotient is much bigger. This is the opposite of the last few lessons we've done. All right, now same thing's happening on lesson 14. They're just some word problems. So we have to be able to identify what's being shared by the number of sharers, or what's being split, or what my total starting amount is, and then the number of splits, piles, people, all that. Same thing we always done for division. So you got to stop and think. 1 serving of granola is a half a cup. The bag of granola holds 5 cups. How many servings are in the bag? Well, I know I have to find out how many 1/2s are in 5. So that means I'm starting with 5 and I'm dividing it up by 1/2. This is what I'm sharing. This is the size of the thing being shared, or the amount of things that I need to know it goes into. So that becomes, all right, well, if it's 5 divided by 1/2, let's just think about it. This is 1, and I split that into half. I'm going to have 2 sets of the 5 here. Really, it's 5 sets of 2, but that's okay right now. We're just keeping it in order of how we're used to doing it from yesterday's work. So really, I have 2 sets of 5, because look at this. This is 1/2, 1/2, and I have it 5 times. So it's going to be 2 5 times, which is what this is, 2 5 times. So think, the quotient will be greater than 1, since there are 2 servings in 1 cup. 5 cups, there will be 2 servings times 5, which is 5 times 2, which is 10. That's how I get my 10 servings. All right. So again, you have to stop and think and work the stuff out. All right. If you, because I know this is really new, so you may have been nervous. If you were able to get your pencil work done, awesome. If not, we just work on it together right now. Jackie, Jay has a strip of paper that is 4 feet long. So immediately I know the starting amount. She cuts it into pieces that are 1/5 foot long. So I'm starting with 4 feet. And notice I have to identify the size, so I don't think that I'm starting with 1/4. All right, so it's really 4 feet starting, okay? And then I'm splitting the 4 feet, like each foot, into 1/5 pieces. 1, 3, 4, and so it's 1/5 here. But I have 1/5 in 5 slots in each foot. So I have like 5 parts here, 5 here, 5 here, 5 here. That's a total of 20 sets of 1/5 in 4. So what does that look like in terms of division? Well, I have 4 divided by 1/5. That becomes 5 times 4, and that's where I get my 20 sets of 1/5. Obviously 1/5 is like less than 1, but the word sets just reminds us that that's the group in 4, as I can split each one into 5 pieces. So many, such a big thing. And now, because I'm dividing by this like really small fraction, I'm asking myself, how many 1/5s in 4? How many 1/5 in 4? And there's going to be a lot because there's 5 1/5 in 1. Oh, I did all of the things here. My bad. Okay, so I wrote a division expression, 4 divided by 1/5. And then how many 1/5 foot size pieces does Jack Wee Wee have? And so yeah, there's 5 1/5 in 1. So that stands to reason that there would be 20 1/5 in 4. See, 5 times 4, 1 times 4. 1/5 stayed the same. This is what we'll work on in 6th grade with equivalent ratios. So like if I'm multiplying the 5 times the 4, then I'm be multiplying the 1 times the 4. And that's going to know that I have the size that I want, and each one is the same size. Okay. New problem. A piece of wood measures 3 yards long. All right, so that means that I'm going to have 3 yards, and I have to name it. It's not 1/3. It's going to be 1 yard, 1 yard, 1 yard. So it's 3 yards. All right, and then each yard is cut into 1/3 of a yard piece. So that means I have 1/3 of the 1 yard, and I have 1/3 of this second yard, and then I have pieces that are 1/3 of this third yard. So it looks like I have 1, 2, 3, 4, 5, 6, 7, 8. So I have 9 pieces because I have 3 divided by 1/3. And that means I have 3 sets of 3, which is 9 overall parts. Let's see which diagram works for us. Well, this one has 3 divided by 1/2. I would get 6. Can't be. I need 9. This one would have 3 split into thirds. That would be 9, looking good. And then let's look at this last one just to make sure. I have 2, right? 2 divided by 1/3, and that's only going to give us 6 pieces. So C is wrong. All right. Here we go. Okay. Let's look at the next few problems. I love these scenario model and equation problems. All right, so 6 candy bars are each cut into thirds. How many people can each receive 1/3 of a piece? All right. So actually, I know that this is 1 bar. I have to be really careful that I don't get confused. This is 1 bar. So altogether, there are 6 bars. That's really, really important. That we know that we're not starting with that like a fraction there. We're starting with a whole number. That's my starting amount. That's what I'm splitting up, 6 candy bars. And I'm splitting them up into what size piece? 1/3 of a bar. So if I have 6 divided by 1/3, I want to know how many 1/3s in 6. Well, you know what? There are 3 1/3s in 1. So if I have 3 times 6, that's going to be 18 pieces out of 6 bars. So I can share with 18 people. Lucky people. Not a big bar though. 1/3. Not a big amount, I mean. All right. Let's look at the next one. We only have this picture and then this diagram or this equation. So it says 2 divided by 1/2. So I have 2, and I need to name this as wholes instead, so we don't think it's a fraction and then get confused. So if this is 1 and 2, I have 2 overall, and I'm splitting them into halves. This is a half, 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 half. I have 4 of those. So let's come up with a story for that. And then I have 4 1/2s in 2. Okay. I'm going to bring Miss James into this. Miss James had 2 yards of fabric. There's my 2. And she wanted as many pieces of 1/2 yard length she could get. How many in 4? No, so sorry, in 2 yards. How many, what is it, 1/4? No, how many 1/2 in 2 yards? Okay, so Miss James had 2 yards of fabric to start with. She wants, unless to be writing, she wants as many pieces of 1/2 yards of fabric she can get. How many 1/2s into yards? Okay, this is the word get, sorry. All right, so if I have 2 yards, that's what I'm starting with. I then divide it up by 1/2. I have 4 pieces of fabric for Miss James. Yay. Okay. 5 cups of whipped cream split into 1/4 cup servings. Immediately I'm thinking I have 1 cup 5 times. 1 cup 5 times, 1 cup 5 times. So I know that each of these is a whole. And then I'm taking 1/4 cup size servings in each one. So 1, 2, 3, 1/4. Means that I have 4 in each one. So if I have 5 divided by 1/4, okay, I have 4 parts in each 1 cup. So let's see what that looks like. 5 divided by 1/4. I have 4 in each 5, and it's going to be in each of the 5 cups. It's going to be 4 times 5, which is 20 servings. And I think it's really important to go back and write the context of the problem. It takes an extra second and gives you a more complete answer. And sometimes the problem actually asks you to write it in context. Okay. Lesson 14 is more of the same, just some word problems, which I think sometimes makes it a little bit easier. All right. So we have 3 cups of pistachios. Let me just draw that out. 1 cup. 2 cups. 3 cups. No, my bad. I'll write 1 cup here because it represents the 1 cup. All right. And each serving of pistachios is 1/4 cup. So let's split that into 4ths. How many in one of those cups do I have? 4 servings. And if I have 3 cups, it's going to be 12 total servings. Let's see what we got. What am I breaking up? I'm breaking up those cups of pistachios. And I'm breaking it up by 1/4 size servings. Okay. That will be my dividend is the 3, and the 1/4 is my divisor. And then my quotient is going to be how many 1/4s in 3. Well, ask yourself how many 1/4s in 1? 4. 4 times 3. 4 times 3 is 12. All right. How many 1/4s in 1? 4. 4 times 3 is 12. Okay. Next one. Oh, explain with the model. That's what I did. Okay. All right. Let's look at the next one. 1 serving of a cereal cup is 1/3 of a cup. All right. Oh, the box holds 8 cups. This is exciting. How many 1/3 cups of servings are in the box? So let's take a look. I'm going to draw my 8 cups because I think it helps. All right. So this is 1 cup, 8 total. 8 total. All right. And then I know that my cups are split into thirds. Every single one of the 8 cups is split into thirds. So how many servings is that? Looks like I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. I have 24 servings. So that means I have 8 cups. That's what I'm splitting up. What am I sharing? What am I dividing? Divided by the size of the thing being shared is going to tell me how many total servings. And that means that I'm then doing 3 in 1 times 8. If I have 3 servings in 1, 3 servings in 1, I'm going to do 3 times 8, which gives me 24 servings. All right. Okay, so let's look at the last one. We're going to take a situation, we're going to pick an expression, and we're going to solve. Morris has 2 gallons of milk. So already I'm thinking that's definitely the dividend. I'm starting with that number. He pours the milk into containers that holds 1/5 cups each. How many containers does he fill? All right, I'm selecting this one and I'm solving. 2 divided by 1/2. How many, 2 divided by 1/5. How many 1/5s in 1? 5. 5 times 2 is 10 containers. Right? How many 1/5s in 1? 5 of them times 2. Okay, let's look at the next one. Tyler has 1/6 of a pizza pie left. He shares the pie equally with 2 friends and himself. So that's 3 people. I'm writing it down. How much of the whole pie will each person get? Well, I'm starting with 1/6. That's my starting point. So I have to just divide 1/6 by 3. And remind yourself, if this is a whole, and if I'm splitting each one now into thirds, remember I'm taking 1/3 of the 1/6, and that's going to be 1/18 of the whole. All right, so it was super duper small, but I also started out with a fraction, and then I divided it by a whole number. All right, let's look at this next one. Sam has a piece of string that measures 7 feet long. I'm thinking that's my starting number. She cuts it into pieces that measures 1/2. How many 1/2 foot size pieces does she have? All right, well, I have 7 divided by 1/2. If I have 7 divided by 1/2, I'm asking myself, how many halves in 1? Oh, there's 2. 2 times 7 is 14 pieces of string. Okay, because the division, that second number, the divisor, I'm flipping it. I'm getting 2/1, because how many 1/2s in 1 is 2. 2 times 7 is 14. All right, and let's take a look at the bottom view. We'll do them together. If I have 10 divided by 1/3, I'm going to say, I have 3 of 10. That's 3 times 10, and that's 30. If I have 9 divided by 1/3, I have how many 1/3s in 1? Oh, 3. 3 times 9 is 27 total pieces. If I have 15 divided by 1/2, oh, how many 1/2s in 1? 2. 2 times 15 is 30. If I have 1 divided by 4, or 1/4 divided by 6, asking myself, I have 1/4. I'm taking 1/6 of 1/4. And I'm going to get 1/24, something super, super small. If I have 1/7 divided by 10, I'm taking 1/10 of the 1/7, and I'm getting 1/70th, small. And again, if I have 1/10 divided by 8, I have a super duper small fraction split up into 8 pieces. I'm going to have 1/8 of the 1/10, and that's 1/80th of the total. All right, that's really tough work. Your brain should feel like it had a good workout. And I will see you tomorrow. We won't have official homework tomorrow, but I will hand you the study guide for the Unit 3 test, which is in about like 6 or 7 school days. All right. See you in the morning. Night.